the set of residue classes. Now, remember a bit of revision. Two numbers are said to be, what's the word? Congruent. Mod n if a minus b, or if n divides, divs, a minus b. Okay? Now, now this is just a revision, that your set of the integers, you can divide that, or partition, and I'll use that term later. Partition just means to cut up, like you take a machete and you take a large watermelon and you just slice it up. You have partitioned that watermelon. So if you put the parts together, you get the whole. Now, if I hit one, this is a bit of revision. Now, what do these mean? These are, separately, residue classes. So what does that mean? What is a residue class? Well, from previous lecture, a residue class is an infinite set of all those integers that are congruent to 0. That's one set. Now, a different set, quite distinctly, quite different from this one. This is the residue class, and it is the set of integers, an infinite set, where every member of that set is congruent to 1. Right? So, for example, or modulo n. So, for example, this would be the infinite set 1 plus or minus n, 1 plus or minus 2n, and so on. Okay, infinitely. And similarly here, this is the residue class mod n. So it would be an infinite set, and it would take the form n minus 1, n minus 1 plus or minus n, n minus 1 plus or minus 2n, and so on. Okay? Now, so you can partition or slice up, divide the total set, z, that's all the integers, and so this, you could put here the residue class, this one, and here you can put 1. Okay. So you've partitioned or cut up, sliced up your z watermelon, so to speak, into residue classes. So dot 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 dot, and at the end here you'll have n minus 1 n. Okay? Now, so what is z subscript n? What is that? Well, this is a class. Well, yeah, it's a class. It's a set, right? And each of these residue classes is a set, an infinite set, discrete, countable set. So Zn is in fact the set of these sets, right? And if your modulus is n, there will be n of these residue classes. Right? There'll be n of them. And interestingly, we did that a bit last lecture, that these residue classes, they act a bit like integers, like you can add them and multiply them. So let's prove that if the, let's see, what is theorem 13? So the binary operator, yeah, we have to show that this is a group. So the binary operator is simply plus, okay? And the set S is the set of sets in a sense. It's the set of the residue classes. So let's prove that that set and the binary operator plus is a group. Okay, so we have to go through the 4 steps again, as usual. To prove a set and a binary operator is a group, you have to prove those 4 properties. The 4 properties: closed, associative, there is a unit, and each element has an inverse, a unique inverse. Right? Now, from the previous lecture, just a bit of revision. So let's say we're talking about in the context of mod n, right? Here. Remember, this is the definition for 2 integers, a and b, to be congruent, is that a minus b can be divided by n. Right? So in the context of modulus or mod n, okay, that, sorry, it should be a plus. Now, last lecture we actually proved that this is the same thing as this. If you're a bit scratchy on that, go back to the previous lecture and look about this. Look at that proof. All right. Now, if a plus b is bigger than n, or equal to n, greater or equal to n, then just subtract n from this. So then you do this, right? So then that would give you a number that's less than n. Now, why do you do that? Because we're talking about congruent numbers, right? So if you add your a and b and it goes over n, it's bigger than n, well, if you subtract an n from this sum, it doesn't change anything because you're talking about congruent numbers, okay? So this number here will, so it will be less than n and greater or equal to 0, right? Because your smallest one is 0 here. So that's true. So this sum here, and if necessary, you can subtract n from it. So this number here is less than n and greater or equal to 0. So in other words, this a plus b minus n, or a plus b, right? This or this is one of these, okay? And the set of all these is Zn by definition. So I'll write that out explicitly. So Zn is defined as that's your Zn. That's how it's defined. I put 3 bars here as is defined as, and that use of the 3 bars is quite distinct from this one. Here the 3 bars mean that these 2 integers are congruent, okay? And here it just means by definition. So be conscious of the distinction. Right? This is quite a commonly used notation. 3 bars is just the way to say is defined as. Okay? So this is defined by this set of sets. Each one of these is a residue class. Okay. Right. So So this or this, whichever it is one of these. So therefore the result belongs to this set. Okay, so it's closed. So we tick that for this case. Right? Now, is it associative? So